So I'm Carys, I'm the Centre Manager from the UK Carbon Capture and Storage Research Centre. And we're co-hosting today's session with the Supergen Bioenergy Hub. And we'll be discussing BECCS, different pathways and options for bioenergy with CCS. So I'm just going to give Patricia Thornley, who's the director of the Supergen Bioenergy Hub, a chance just to introduce a little bit about their hub to us before we start today's session as well.
Thanks, Carys, and hi everyone. So Supergen Bioenergy Hub has been running now for a very long time. I think we have had 25 years in total of existence. I haven't been involved for quite that long, but what we are now in is perhaps the most relevant thing. We're in an impact phase of the hub, and that means that we are working with industrialists, some of whom will be presenting in the next half hour or so, to deliver around biomass and bioenergy. And one of the most important things that's happened in this space in recent time is the biomass strategy, which was produced by UK government last August. And that made it very, very clear that what was important was negative emissions, and that should be the top priority for biomass use in the UK. So never could it be timelier than to be talking about BECCS, biomass to energy with carbon capture and storage, which is often considered to be the front runner in terms of how to deliver those negative emissions. So yes, pleasure to join up with UKCCSRC today and to bring both hubs together in order to look at this really important topic with people from both academia and industry, because we really need to bring this together in order to make progress on things.
Great, thank you, Patricia. And yeah, thank you in advance for all of our speakers today. We've got a really exciting lineup. So we've got 6 different presenters today from academia, from industry. So we'll be discussing a range of topics around BECCS. So it'll be slightly different to our usual format. Each speaker is going to have around 5 minutes to present, and then we're going to leave longer at the end of the session for a Q&A and a panel discussion. We've got some great presenters today, so we really want to make space for the questions from yourselves as an audience and for our panel to discuss with each other a little bit about some of the things that will come out of today's presentations as well. So first of all, I'd like to introduce Salman Masoudi Soltani from Brunel University, London. And I'll hand over to you, Salman, for the first presentation.
Thank you very much, Carys. Well, good afternoon, everyone. Before I start, I'd like to thank UKCCSRC and Supergen for having me today. I'll load up my slides in a minute. So hopefully everyone can see these.
Yes, they look great, Salman.
Yeah, perfect. Thanks, Carys. Right. So I'm Salman. I'm from Brunel. I'm a senior lecturer in chemical engineering, and one of the research that I've been involved in has been basically exploring the potentials of DRAX biomass combustion residues in carbon, in carbon capture. Now, I'm going to be talking a little bit about the why, the how, and what then. So obviously, as for the why, we're talking about BECCS. Everybody who is here, I'm pretty sure, is more than familiar with the concept of BECCS and negative emissions. So basically, if we burn, sustainable biomass and then manage to capture that, CO2, we're going to be looking at the technology that we refer to as negative emission. Now, DRAX has been very, very active in terms of, biomass combustion. Obviously, they're having very solid plans to capture the CO2, meaning that DRAX is basically going to be looking at, negative emission technologies within the coming years. However, conventional solvent-based capture technologies that are associated with a range of issues that we can see here, and due to this, we should do something about it. Now, one of the issues with, burning biomass to generate power is obviously the solid residues that we end up with, and they are mostly, fly ash and bottom ash fractions that are collected at different locations at the plant. Now, the main difference now between coal ash and biomass combustion ash is the physical and chemical properties of this ash kind of material. And because of the presence of a specific compounds, we cannot really deal with biomass combustion ash the same way that we deal with the coal fly ash and bottom ash. And what is the alternative? So this has been the research question in some of the work that we've been doing here. And what we have done, we've looked into the bottom ash fraction and the fly ash fraction generated a DRAX power plant, and we basically came up with some ideas as what we can do with these waste residues. So using the fly ash at the top, we managed to basically synthesize some zeolitic absorbent material, which we then used in capturing CO2. And also we looked at the bottom ash fraction, and we managed to extract virgin carbon without any pyrolysis. So it was a very straightforward direct extraction process, which we developed, and we managed to produce some very good quality carbon. I'm going to be flying through these slides because I don't think we need to talk about this at this stage. If you have any questions, please do feel free to just throw the questions at me. But in summary, we managed to notice a good decent amount of capture capacity with both sorbent material that we synthesized and activated. And obviously the next stage was to test the material in a fixed bed column, and that was part of the one of my PhD students' projects, who put together a temperature swing adsorption unit, which we then used to test some of the material. The column then gave us the breakthrough curve, obviously a characteristic of the column, which allowed us to manipulate some of the operating conditions in the bed and better understand the mass transfer behavior with the sorbent material and the column that we have in the lab. Now, in terms of what then, obviously, we've synthesized the material, we've done the equilibrium and kinetic studies, we have activated and modified the solid sorbent material using these base streams, and we are now doing the reactor studies. Obviously, the next stage, we are aiming to put together a process model, which is then experimentally informed with the data that we have collected in the previous stages. And then we use that model to do hopefully some economic analysis within the coming month. If you're more interested in the details and you would like to read more about the the nature of the work, please do refer to some of the papers that we have recently published on this topic. And I would say at the end, I would also like to thank my PhD students and postdocs who have been working in the lab, allowing this whole research to basically take off. Thank you.
Thank you, Salman. That was great. And keeping to time with 19 slides, I'm very impressed. So yeah, thank you, Salman.
Thank you very much, Carys.
So next we have Karl Smyth. So Karl Smyth joins us today from Infinium. So if I can hand over to you, Karl, once you're able to share your screen.
Yeah, thank you, Carys, and thank you again for having me today. So I'll start with just a very quick overview on Infinium for the benefit of everyone attending the webinar. So Infinium, it's a relatively new business. We're 3 years old, but we're quite a significant business in the context of the UK's waste sector. So we have 6 facilities operating or in construction around the UK. That means that we're the 2nd largest operator of energy from waste in the UK. We process, when our 2 facilities, which are currently in construction and are due to commission in late 25, early 26, are online, we'll be processing about 3 million tons of unrecyclable waste every year. That will enable us to generate about 340 megawatts of homegrown baseload power. But I think for the purposes of this session, the more interesting opportunity is the ability, when we retrofit our assets with CCS, to become a carbon removal business. And we set out that vision in a document that we published 2 months ago called our Net Zero Transition Plan, which sets out the strategic case for us retrofitting CCS across our portfolio. Number 1 is the UK waste sector, as some people will know on this call, is entering the UK emissions trading scheme in 2028. So Across the UK, there's about 50 plus energy from waste facilities treating unrecyclable waste. They treat up to about 20 million tons of unrecyclable waste every year. Of that waste, roughly 50% is from biogenic sources of waste, food waste, paper, packaging, and 50% is fossil derived, primarily from plastics. So that means that every year, of that 20 million tons or so of waste that is being treated through an energy from waste facility, around 10 million tons of fossil is going up into the atmosphere and 10 million tons of biogenic. So there is clearly, from a decarbonisation perspective, a need to address that. Separately, even though the UK has quite ambitious recycling targets and is bringing in a range of new policies over the coming years to improve our recycling rates, the UK government's own forecast estimate that there will still be about 17 million tons of unrecyclable waste every year by the time we hit the early 2040s. So there'll still be a quantum of unrecyclable waste that society is producing that will need to be managed carefully and treated sustainably. Therefore, our vision for the future of the sector is a smaller number of plants than we have in the UK today, but to have those as decarbonised as possible, and the principal decarbonisation pathway we see as carbon capture and storage. So we ourselves announced an investment plan of £1.7 billion to retrofit the 6 assets that we have in our portfolio to CCS. In doing so, because of the biogenic fraction, we believe we could hit net zero as a business as early as 2033. And then as we continue to retrofit CCS across the portfolio, we could actually scale up to become a carbon removals business, removing 1.2 million tons of carbon from the atmosphere by the late 2030s. And then we scale that up across the UK and the potential for the wider sector. We've just done a study, supported a study from Oxford Institute for Energy Studies, which shows that the UK energy from waste fleet could be generating anything from 5 to 8 million tons of high integrity carbon removals every year, which is a very significant contribution to the UK government's overarching net zero targets. So I think this is kind of boils down what we see the proposition of energy from waste facilities as being in the future. So today we provide an important service diverting unrecyclable waste from climate damaging landfill, which produces methane. But in the future, an energy from waste facility with CCS can do two things. It can do high integrity carbon removal credits, which is underpinned by a sustainable feedstock and a robust monitoring, reporting and verification regime, but it can also produce carbon negative energy, and that could be used in power, but also in heat, hydrogen, other pathways as well. And then I'll just conclude by bringing this to life with a short case study. So in the north of Wales, we have a facility called Parc Adfer that effectively takes all the unrecyclable waste across North Wales. It's a partnership with the North Wales Residual Waste Partnership. It's been operating since 2019. We've recently submitted the project into the government's Track 1 expansion program, so we would like to bring CCS to this plant. If we did so, it would create over 100,000 tons of high quality removals every year from 2030. So that would be the first building block in a much bigger strategy to decarbonize our operations. I'll pause there. Thank you very much.
Thank you, Karl, and some exciting and impressive net zero targets there as well as a company. So next we have Paula, Blanco-Sanchez and Fabian Ejim. I think, Paula, are you able to present at the moment? Great. And you're on mute at the moment.
Yeah, I will try. Just going to share the screen.
And Paula joins us from Aston University today as well.
Thank you, Carys. Can you see my screen?
It's thinking about it. That's up and perfect. Thank you.
Yeah?
Yes.
Okay. So good afternoon, everyone. Thank you very much for the invitation and for having me today. I'm here with my colleague, Fabian Ejim, who is the person actually working directly in this project I'm going to talk about. So we've seen this diagram description from Salman earlier in the first presentation, and one of the technologies that can be used from the BECCS approach is gasification. In the area that we are working at Aston University is looking at gasification to produce low carbon hydrogen, and looking at how we can achieve an optimization of this process from looking at the integration and the challenges with other areas. So looking as well at the theoretical potential of biomass energy with carbon capture and storage, and essentially if we can achieve these negative emissions. We need to look as well at how are the different technologies that are available. Enfinium already gave a very good description of the ambitions in terms of what carbon capture approaches can be out there and different TRL levels, and what is the role that they can play in meeting the global energy and climate goals. And also when looking at a more local level or national level here in the UK, how they can contribute to achieve net zero goals. For capture of CO2 from large point sources as well, looking at how this can be achieved from industrial perspective, and the different options once the CO2 is captured, if it is going to be utilized in pipelines, ship or rails or other approaches, and also for storage, thinking about what is the potential in the UK for store CO2, and also the available commercial capture facilities that are operating globally with a total annual capture capacity of about 45 million tons of CO2. So all these approaches and different developments play an important role in how we can optimize the whole process and to ensure that we are supporting the deployment of the gasification in this case. But there are still several challenges, and maybe Amna will cover some of this later in from the Q technologies perspective. But when we are looking at the syngas production and all the tar and contaminants or the feedstock, the nature, the availability, the design of the gasification technology as such, and different operational conditions and process integrations. All these different parameters play a major role on how we can support the deployment of technology for different applications. But also the cost is very important. So in the case of hydrogen, the cost of production is very dependent on this technology and the cost of energy source. And this is different for different regions in the world. But also the production cost is only a fraction of the final cost, because also the conversion and reconversion cost, transportation needs to be taken into account, equally like the availability of existing infrastructure and feedstock prices. So when looking at what is the most effective approach for BECCS, one of the most common approaches is saying, well, we need to use different technologies in combination and not relying only on BECCS, but biomass combined with heat and power and biohydrogen with CCS, and the cost optimal combination of these technologies as a function of the hydrogen and electricity and heat prices. So we could achieve this cost optimal supply chain network by minimizing the supply chain cost and also CO2 removal targets. And in this diagram, we can see some of the approaches involving these different combinations, including how the gasification can play a role in this, and if we can actually deliver negative emissions by using this technology. So what we are doing here at Aston University is looking at these challenges in integration. So we are looking at the implementation of the Wolfson Center for low carbon hydrogen production, and including gasification, membranes, and solid oxide fuel cells. And we are not looking only from the technology and experimental point of view, but also how we can integrate these using different approaches like digital twins to optimize the processes, And this is the reactor that we will be installing soon as part of this research center. So if anyone is interested in any of the areas that I'm showing here, development of novel catalysts, hydrogen separation, syngas utilization, process integration, and use of digital approaches, we are more than happy. Please reach out to us. So that's it from me. I hope that was within time.
Thank you, Paula. Perfectly in time as well. So thank you for that. So next, we're going back to an industry focus. So we've got Gareth Johnson speaking to us next from DRAX.
Thanks, Carys. Can you see my slides? Are they up?
Yes. Yes, they look great.
Great. Perfect. So thanks, everybody. Thanks for the invite to talk today. So my name is Gareth. I'm from DRAX. I'm just going to very briefly introduce you to DRAX. If you don't know who we are, tell you a bit about our net zero journey. And I'm in the sustainability team, so I want to talk a little bit about sustainability around BECCS. So let's try and make this. There we go. Who are DRAX? We're a global renewable energy company. You might know of the DRAX power station in Yorkshire, of which the company is named after. But we also have hydro assets in Scotland and pump storage facilities too. As part of the DRAX power station conversion to biomass over the last few years, we've also developed a biomass supply chain as well, so pellet facilities in the US and Canada. And we're big. We generate a lot of electricity across the group. We are the single largest point source of renewable energy in the UK, and currently provide about 8% of that renewable energy in the UK from the group. And ultimately, we want to be removing large amounts of CO2 from the atmosphere. So a little bit about our journey then. 2024, we're now 50 years from the opening of DRAX power station in 1974, celebrating our 50th year this year. The first phase of DRAX really was coal burning at DRAX power station, providing a huge amount of electricity to the grid, up to about 4 gigawatts of electricity at peak. And that lasted for about 30 or so years. And then in the early 2000s, there was the second phase of DRAX's existence kicked in when we converted to biomass energy. And that was completed in the 2010s. And we're now on our journey to negative emissions. And you can see we've got a number of milestones there that we're already over, but ultimately we're aiming to deliver significant amounts of carbon removals, millions of tons of carbon removals by 2030. Today, you're hearing lots about different kinds of BECCS, and so our particular shape and flavor of BECCS, if you like, is power generation. So we are a power BECCS operating utility. We want to fit carbon capture and storage to our DRAX power station in Yorkshire. We also want to build new build electricity generation with CCS in the US. And fundamentally, our sourcing comes from forestry residuals, and I'll talk about that in a minute. So our sourcing is from forestry residuals, and we're generating power. That's our business model. In terms of that sourcing, very briefly then, so we are part of a forest industry in which the primary economic driver of the forestry that occurs is production of saw timber quality wood. So this is wood that goes into construction, it goes into furniture making. And that drives a higher price than DRAX or anybody else in the bioenergy would ever pay for bioenergy. And so what we do, instead of taking that high quality wood, we take the byproducts of that process. So we take the low quality, low value wood that gets produced at the same time as these as the high quality saw timber does. And so you can see these are our numbers for 2023 group wide sourcing. And you can see nearly half, 44% of our sourcing comes from sawmill residues. So this is the chips, the shavings, the sawdust that comes out of the back end of a sawmill. And just over half, the remainder of this comes from forestry residuals. So this is the byproducts that come out of the forest, be that the low grade wood that can't be used for that high quality saw timber, be it the thinnings that happen as we're managing the forests over time to grow bigger, stronger trees for the saw timber, or be that the branches and the tops that come come with that. And you can see we have a very tiny amount there of agricultural residue as well. Essentially, all of our sourcing comes from areas that are strongly regulated, strongly controlled, and we have confidence in the systems there to know that the biomass that we're sourcing is sustainable. Just briefly then, before I finish, the questions around BECCS and sustainability are broader than biomass sourcing. Biomass sourcing is a huge piece of the puzzle, but there are lots of other aspects that we need to consider as well. And I just wanted to flag, I don't have time to go through this report with you, but a couple of years ago, DRAX commissioned an independent third-party inquiry led by an NGO called Forum for the Future and chaired by Jonathan Porritt. And they wrote a set of conditions under which they proposed that if you're going to do BECCS, this is how you do BECCS well, how you do it sustainably. So it's called BECCS Done Well. We just published about 6 weeks ago our final response to that. And in that final response, you'll be able to dig into all the details and see exactly how we responded to those conditions and how we're operationalizing those. And you can see the main headings there, everything through the impacts that we have to people, to nature, and to climate, and the fact that we're underpinning a lot of this through transparency in reporting and the application of the best science possible. So that was it from me. A couple of QR codes here for those two reports if you want to go away and read them, and I think UKCCSRC will share these slides after, so you can pick them up from there. Thank you very much.
Thank you, Gareth. So we're on to another research presentation. So we're alternating. So next up, we'll be hearing from Alberto Almena from the University of Salamanca. And I'll hand it to Alberto.
Yeah, let me share my screen. Please let me know if it can be in full screen mode.
Yes, that's great.
Okay, great. So thank you very much. I'm Alberto Almena, and I'm going to speak some research that we have currently published that is involves the investigation of sustainable aviation fuel production with integrated carbon capture and storage. So just to briefly introduce myself, I come from Spain, Zamora. I did my bachelor and master degree in the University of Salamanca, and then I moved to the UK to do my PhD and working as research fellow at Aston University with Patricia. And then I moved back recently to the first university, the University of Salamanca, which is the third oldest university worldwide. And I'm working in the process system engineering group lab when we improve process system engineering, techno-economic assessment, and environmental assessment. And this is where we are based now. Going more into the topic, international aviation was identified as one of those sectors that kept increasing the environmental impact. And the UK acknowledged that and introduced this in the net zero pathways, creating a carbon emission mitigation budget that involves the reduction of emissions caused by international aviation and targeting a percentage of the SAF share in the fuel mix. So we wanted to investigate this scenario, and we suggested investigating the use of biomass residue that do not have a land use change penalty, as is it there, specifically forest and waste wood, in order to be converted to sustainable aviation fuel and introduce carbon capture technology within the conversion process. So there is no data. We had to model this process entirely to perform the life cycle assessment. So CORSIA is the global framework governing the international aviation emissions accounting. The objective of this framework is to freeze emissions to 2020 levels, and there are limited conversion technologies that participate within this CORSIA framework. So we wanted to investigate one of those routes suitable to integrate carbon capture and storage technology. We wanted to predict the CO2 footprint of this system and make policy recommendations based on the conclusions extracted from this work. The synthesis route, with accounting all these features, was the Fischer-Tropsch process. And this is the system boundary for the well-to-wake approach that we investigated, incorporating biomass production conversion, carbon capture technology, the mix or blend with the conventional jet fuel to have a certified blend stock that can be operating jet engines. So we had to model the SAF process. I am not going to stop here. It was a complex model involving all these core blocks, optional blocks to increase or maximize the yield to the hydrocarbon fraction that we are interested in, and some auxiliary blocks. It was solved in Aspen Plus, and we extracted the mass balances, energy balances, and equipment design to feed the life cycle assessment that we were doing later on. So the results from the process modeling was that the process has an energy efficiency of 51%, producing 7 tons per hour of SAF from 62.5 tons per hour of dry biomass, along with other hydrocarbon fractions that, like in a refinery, we are obtaining at the same time. So we could track the fate of the biogenic carbon entering the system. We saw that 36% went to the liquid fuels, while 44% was permanently stored and prevented to be released back to the atmosphere. The life cycle assessment that was performed over this system was compared to the conventional jet fuel, fossil fuel used for aviation, that has a net fossil emission score that equals the net greenhouse gas balance, in this case, all is fossil, and has a score of 81.8 grams of CO2 per megajoule of fuel used. So if we use the certified blend, because currently jet engines cannot operate with the 100% SAF blend, we could achieve a 37% reduction in the fossil carbon that is emitted to the atmosphere, and the net balance was a 63% reduction, also involving the biogenic carbon dynamics. If those engines were capable to operate with 100% SAF, we could see that the reduction was doubled, and we could achieve the system to have a net negative greenhouse gas balance. So just briefing the conclusions from this work, we saw that SAF represent only the decarbonization solution for the short term. The biogenic carbon that is commonly accounted as climate neutral, we should not be stuck on that, because we missed some potential like carbon capture technology if we do that. When the AST blend certified reduced 37% of fossil emission reduction when compared to the conventional fuel, we could fly with net negative emissions if the jet engines were adapted to operate 100% SAF, and we know that some companies are trying to achieve that. We saw that this route rivals with synthetic e-fuels in emissions reduction, but requiring less energy. And for policy recommendations, we saw that the carbon emission target for 2030 could be achieved with this route, but unfortunately, the mid-share is not possible to be achieved due to the resource limitations. This work is published in this link that we saw below. And thank you for your attention. And later in the Q&A section, I can answer anything that you want to ask me. Thank you very much.
Thank you, Alberto. Really interesting and different angle of BECCS coming in there as well. So next up, we have Amna Bezanty, who's speaking to us from Q Technologies today. That all looks great, Amna.
Thank you. I just had to unmute. Hi everyone, I'm Amna Bezanty from Q Technology, and I'm here to present today a bit about one of the more novel and innovative solutions of BECCS via advanced gasification technology. Just a high level in terms of where we fit in the market, we see ourselves at the start of two parallel market revolutions. On one hand, we're here to address the energy trilemma and address the displacement of fossil fuels and providing energy in an affordable, sustainable and secure manner. And we do that by using waste and resources and biomass resources, looking to create a circular waste hierarchy and adding an additional step in the hierarchy where you look to prioritize molecules for harder to abate sectors, waste for harder to abate sectors, and create molecules a bit different from traditional waste energy, which is typically electricity and heat. We look to take waste and biomass and create molecules for industrial decarbonization, transport decarbonization, chemical decarbonization, etc. Not sure if decarbonization is the right word, as you still need carbon for all of these. Some argue defossilization is a better description, but generally you get the gist. Very high level intro into Q. We're a sustainable energy solutions company who've developed our own proprietary technology and proven that at commercial scale on the picture that you see on the right. And we've been in development for over 10 years and are currently in the early stages of commercialization, working very closely with end clients and early adopters to replace existing fossil fuel use in their operations, and also working extremely closely with waste majors and helping them achieve their net zero ambitions for their waste supply. A bit about gasifications for those who are less familiar with it. Many know about combustion and burning and incineration of waste to generate energy, which uses high presence of oxygen. Quite a bit know about pyrolysis as well, which typically pyrolyzes plastics and tires. Gasification sits in between with the right balance of oxygen and steam. You're able to gasify solid feedstocks into what we call synthesis gas, syngas in short, and that's then what you move forward with. How have we done gasification differently? Our technology focuses on, many others have done gasification where you take waste feedstocks and convert them into syngas, but that syngas is dirty, number one, because it has a high presence of tar, and number two, depending on the feedstock, your syngas composition isn't consistent as well. So as you can see on the graph on the left, each line represents a different feedstock, and it's all over the place. And where our technology comes in is not, we have that stage, of course, to gasify the waste into syngas, but we also have a second critical stage in our advanced gasification process, where using a proprietary equilibrium approach reformer based on petrochemical sector, you use high pressure, high temperature with a certain residence time, and you fully crack the hydrocarbons present in that waste, and you also create a consistent syngas composition, which therefore makes it carbon capture ready for pre-combustion capture, which is also actually a more cost-effective form of capture, where the CO2 is at higher concentration, and it's also a cleaner way of removing CO2. And as a result of this equilibrium approach reformer, we're able to target a wide range of feedstocks, all the way from wastes, which are mixed, biogenic, and recycled carbon, all the way to sludges and digestates, with form of bioenergy, as well as pulp and paper byproducts of paper production and things like that. So that really helps with the feedstock availability aspect of things. And it's not all just on paper as well. We've proven this at commercial scale in a demonstrator at the Sustainable Energy Centre, 20 minutes away from Birmingham, which currently produces tar-free syngas, which is the reality today, into the engine. But we're currently constructing a syngas to hydrogen with carbon capture facility add-on funded by DESNZ. We actually also have space, so if you're interested in also demonstrating SAF and methanol, we've done some assessments for that, so do get in touch. And last but not least, with regards to the technology, one of gasification's other biggest challenges, as well as addressing the tar problem, has also been the scale-up risk. We're de-risking scale-up by not scaling up the actual process, because we operate at pressure around 8 bar. The physical footprint of our process is 1/8 to 1/10 smaller, so we can factory build the plants. And the way we're scaling up is because it's modular build, you go from, each plant takes around 20,000 tons a year of waste, so you just go from 20, 40, 60, 80 to 100 to 200,000 tons, up to 300,000 tons a year of waste. So it's a de-risk scale up as well. It's also quite efficient because it makes the process scalable in terms of you're able to scale the process based on project requirements, and very helpful for waste catchment areas as well, which means the waste or biomass feedstock will not need to travel huge amounts to get to where it needs to be. So kind of local solutions and local energy production. Overall, there's strong ESG credentials, even without CCUS, but most importantly, and the focus of today is BECCS, is it's one of the very few technology pathways that offer a pathway to negative carbon. And we believe it does so as well at cost-effective count per ton of CO2 as well. And that's why we received the DESNZ funding, but happy to get into more detail after this. This just summarizes a bit about how we've overcome the gasification challenges, and as a result of it, we create a strong foundation for BECCS via advanced gasification as another pathway. And we also, as mentioned, going to demonstrate this at our sustainable energy facility, thanks to DESNZ, and we'll be producing hydrogen and food grade CO2 from here as well. So do get in touch if you're interested to find out more about that. But just a comment here is, end-to-end demonstration and demonstration facilities in the world of innovation is extremely important, and we're very happy to be able to actually do this in real life and not, just kind of on paper and then do a large commercial scale project. So it really helps with technology de-risking, and we encourage to see more of this in the world of innovation. In summary, we have a parallel track commercialization strategy where we're looking to, due to the modular aspects, we can co-locate with industry, from glass to chemicals to pulp and paper to cement, and displace their fossil fuels using our syngas directly into their clean rooms and furnaces. And we can apply carbon capture to that, especially actually in steel. Blast furnaces need CO2-free syngas as well. So it's not only a route to CCUS, but it's also kind of chemically what certain processes need as well. And on the other side, we also can multiplex multiple modules for times 3 to times 10 to 15 to create small to medium to larger scale fuel and chemical projects, from methanol to DME to hydrogen and other transport fuels as well. And the beauty of it all is they're all carbon capture ready, and you can apply BECCS across sectors, from heating to industrial to transport to chemicals. And we really do need that flexibility and the portfolio of solutions to achieve net zero. Thank you. Any questions? Just let me know.
Thank you, Amna. That was really interesting. It's really interesting seeing the whole breadth that we've got from everyone speaking today. So I'd like to invite all of our presenters and panelists to turn on their cameras so we can set up. Yeah, so we've got all of your cameras ready. I know we've got a lot of questions coming through on the chat already. So on the Q&A, I'd just like to reinforce, please could you ask your questions to the Q&A, because that's where we'll be monitoring to pull the questions out for the session. And I know Patricia already has some questions already in mind and lined up, ready for our excellent panel today. So I'd like to say thank you to everyone who's presented already, because it's all been really interesting, and I'm really looking forward to the discussion that's going to come out of this. So I'll hand over to you, Patricia, to manage the discussion on this and to chair going forwards. You're on mute at the moment, Patricia.
Thank you very much. Great set of presentations, bringing lots of different perspectives. The questions are varied. We've had some questions submitted in advance as well, but there have been a bunch really around challenges that you're going to face in bringing this technology into operation, scale-up challenges, timescale challenges, and quite a specific one around whether this actually makes more sense and is more efficient at large scale or at small scale. So can I put to each of our panelists, please, in turn, and I'm going to go in the order that you spoke, unless you don't want to answer this question. No, actually, I'd like you all to answer it. What do you think the biggest challenges you face are in getting this operational? Does the scale-up question daunt you? Is 2030 the earliest it can be done? And what are your thoughts on the optimal scale in terms of efficiency and cost trade-offs? So the first person I think that we had was, I would have to get Carys to remind me, was it Gareth? I think.
Salman.
Salman. Okay, Salman, let's start with you.
No problem. Right, so I think in terms of what I do personally, in my research group, is the fact that the material that we synthesize is adsorbent material, and if we want to use it for carbon capture, for instance, we have to do proper modification, proper activation, and that would involve cost, obviously. Although conventional carbon capture processes like, using amine or solvents have been in place, for some time now, or they are the most traditional way of capturing CO2. Sorbents are considered to be the second generation, due to the simplicity of the process, how easy we can retrofit this technology to existing plants, and the overall regeneration costs of the material. Lack of toxicity, lack of corrosion of the equipment, all these sort of good things. But the problem is, again, the efficiency of the material. If we want this material to work properly at a scale, that it means that we have to not only increase the capacity of the material, but also we have to make sure that the material is more resistant to the presence of moisture, which is the case in many flue gases that we're dealing with, I guess.
Okay, can I go next, please, to Gareth? Let's get an industrial perspective.
Thanks, Patricia. Lots of questions in there. I'll try and tick off some of them if I've remembered them all. So biggest challenge, I think for us at DRAX, the biggest challenge at the moment is making the business case to get BECCS up and running. And we have our permitting in place. We have a development consent order, which we got earlier this year, which is fantastic. But we still don't have that business certainty from the government in terms of what the final clusters will look like, which projects are selected into which CCS cluster. And obviously that has big consequences for us in terms of what transport and storage infrastructure is built. And just to tick off one of the questions that I noticed earlier, yeah, DRAX will not be storing CO2 at the DRAX site. We will be putting CO2 into a shared infrastructure system, and that will be going to storage in the North Sea. Similarly, for our US projects, again, DRAX is not a transport and storage operator. We'll be linking into it to an existing transport and storage operation to get that CO2 stored. So having that certainty around the cluster sequencing process and also the future business model. So knowing what conditions for those of you not in the know, there's a bunch of different business models for CCS in the UK. One of them is specific to BioBECCS, the BioBECCS business model, and we're still waiting for the final position from the UK government on what that support mechanism will look like. They have a minded to position, we just don't know what the final one is. So that's some of the biggest challenges that we have is around setting up those business models. And I kind of touched on it a little bit there in my answer as well. The other big challenge is the coordination effort, making sure that we're all aligned as clusters and with shared transport and storage infrastructure. So, could we do it before 2030? That was one of the other questions. Our original intention at DRAX Power Station was to be online by 2027 with our first unit. That would have required us being selected into the Track 1 cluster process. We were not, and neither were any projects in the Humber selected as Track 1 projects. And so that has meant that we are now at least 2030 is the earliest point, given the infrastructure build out times that are needed to get to the scale that we will need to transport and store that CO2. Is the scale daunting? Yes. The scale of carbon dioxide removals that we need globally is massive. And the analogy that I like to draw here is that currently in the world, the oil industry moves the equivalent of about 5 gigatons of carbon around the planet. Estimates that come out of the IPCC, estimates that come out of a range of integrated assessment models that feed into that process would suggest that carbon removals are of a similar order of magnitude and potentially even higher, maybe towards 10 gigatons total by 2050. So you're talking about an industry the size of the current oil industry, scaling from essentially today very little actual CO2 removal happening. So, a little over 25 years to build an industry that size. Yes, the scale is daunting. At DRAX, we're not afraid of scale. If any of you have ever been to DRAX Power Station, it's big. One of the biggest coal-fired power stations in Europe at its peak, and still the biggest power generator in the UK at the moment. So we're used to dealing with big things, but not quite at that scale. So I think there's lots of things to get right to make sure that we're all joined up on getting to that journey to net zero together. I think the last one that I jotted down was big or small scale in terms of efficiencies. I mean, clearly there's economies of scale when you build things a bit bigger. That doesn't mean that small scale projects won't play an important role. And it will be very context specific. It'll be entirely dependent on whether you are co-located with other users and whether you're sharing infrastructure. It will depend on the policy support mechanisms that are in place for those users of different sizes. I mean, for us, the two big drivers of the cost for BECCS are really around how much we're paying for our biomass and what our value chain emissions are, our carbon emissions are. And so if you can bring the costs of your biomass down by scaling, then that's useful. And if you can reduce your value chain emissions in any way, then that's that's also useful, and that will bring the costs down. So I think it'll be a bit of a pick and mix, and it will largely be context specific. I'll leave it at that for now.
Okay, I'm going to move to our other two industrialists on this. So I'm going to go to Karl, and then as advance warning, I'm coming to Amna after that with the same question, really. The challenges, the scale up, and one of the other questions that has been asked, if you want to venture into that area, is what are the operational differences? How different is this to operating CCS with natural gas? So Karl, do you want to start on those?
Sure. All easy questions, Patricia. Thank you for that. I thought Gareth did a good job of kind of managing some of them. So I think on scale, so I guess the good news is we're looking at sort of established high TRL amine-based solvent solutions, post-combustion technology to begin with, partly because that's a requirement of the UK government sort of support program. It pushes you in that direction. That's a proven technology, which is good from an investor perspective, because they can understand that and they can take a view on that as to it being bankable. Obviously, the challenge with established amine solutions is they're quite high energy penalty, so 30 to 40% parasitic load. So we will lose a slug of energy to power the carbon capture equipment. So all of that, you need to look at that all and around when you face, I think, the kind of macro challenge, which is, I mentioned our Park Adver project, which is the smallest project in the fleet. That's about 200 million capex or capex plus associated financing costs to deliver that CCS equipment at the site. When you look at our bigger facilities, that number can become 650, 800 million. So ultimately, we will all, as kind of private sector companies, have to go to our lenders and our investors and make a business case to invest in these projects. So that is probably the macro challenge number one, is making sure that that feels investable as a proposition. I think many of us here see a route through that, which is, unlike fossil CCS projects, we can find revenue streams from the biogenic CO2, specifically in carbon removals, whether that's through an ETS compliance solution or whether that's going out to the voluntary carbon market. But I guess we as bio-based developers, broadly speaking, have an ability to find a revenue stream in our captured carbon that fossil plants just can't do in quite the same way. So that helps with the economics. I guess the other big issue is the interface with the transport and storage. So I saw one of the questions in the chat was around the location of our sites relative to the clusters. And I mentioned we've got 50 plus EFW plants in the UK currently, and a few more are in construction or being brought online. Some of those are near coastal clusters and some aren't. And that's just a function of spatial planning and lots of other sort of drivers. So as a result, the ones that are nearest the coastline have the best line of sight into connecting to an emerging sort of pipeline-based network. The ones that are a little bit further away, of which it's a kind of non-trivial amount, they've got to look at things like non-pipeline solutions like rail or road or barge or shipping. And that adds additional complexity and interface challenges and costs. So I think this is what we'll be kind of grappling as we go forward with as a sector, is the plants that have line of sight near a pipeline network are probably well placed to move early. The ones that aren't are going to have to work with the UK government to map out what's the kind of policy solution and the commercial solution and the regulatory solution to enable those facilities to access a non-pipeline transport solution which is commercially viable. Otherwise, unfortunately, I think they're going to have to look hard as ETS comes in and starts to really impact some of these facilities. That could have a kind of net negative outlook in terms of the asset life of some of these facilities in the medium to long term. So I think the key things are investors and bringing investors on the journey, because at some point all of us are going to have to face an investment committee and make a final investment decision in these projects. And then separately, the interface with the carbon capture network, which I think is still a fairly nascent stage in the UK in the right direction, hopefully, but still quite a lot to do to bed those networks down and to give emitters line of sight on how they could connect up to them.
Okay, I'm going to go to our other industrialist, Amna, for her perspective on this. But just as a heads up to our two academics who haven't spoken yet, that's Alberto and Paula. I'm then going to come to you on the question of metrics, which you'll see in the chat. So Amna, first to you on these questions of challenge and scale and how are you going to do it?
Yeah, on the challenge, I think for us as an innovative emerging technology, funding has been a significant challenge, especially when combined with gasification, which hasn't unfortunately had the best track record, especially with more recent news of the US facility that has just been mothballed. And actually, I'm going to link this answer to the second question around scale. We strongly believe one of the reasons we've witnessed such catastrophic failures in the gasification sector is because can't think of a better phrase right now, but the kind of go big or go home approach has been adopted. And we're currently seeing that in SAF right now in the UK, where you're looking at 1 million tons of waste facilities with a technology that is still not fully commercially viable, is still not fully deployed, is still low on the TRL compared to other more proven technologies. So I think just taking an example of Windows Solar and how that scaled beyond many people's expectations, it started small and then it scaled from there. And I think in the biofuels and the CCUS world, we need to, especially with looking at more innovative technologies like gasification, you must start small to build big and scale up over time rather than, proving something at a pilot scale and then scaling up 60 plus times. It's not feasible. There's been several billions invested that have unfortunately gone to waste. But if you start small, it's a smaller investment and you have a lot of lessons learned and you've actually done it in practice, because there's a world of difference between what's in theory on paper versus actually demonstrating it in real life. So I think, and as a result of that, one of the biggest challenges we've had in our journey is raising funds to prove a technology that many others have done, which hopefully had lessons learned, and that's what we focused on. So we've really focused on addressing the failures of other technologies, but it's still not easy. As a matter of fact, we are currently also raising funding. We are at TRL 8 looking to get TRL 9 at our facility. So just a side note. But yeah, so generally funding for innovation is quite difficult. And as a conclusion to that point, I think we've had a lot of government support, but it was probably easier in the earlier days. We see a lot of government support for very early on technologies in the R&D phase. There's a lot of incentives and support schemes for commercially viable, go-to-market ready projects and solutions, but there's a bit of a funding gap in between where you've proven it, you're not at pilot scale anymore, you're just before TRL 9 and fully commercially viable, and that funding gap and / what some call the valley of death that continues is very challenging for us personally. And then on the scale bit, I made my point, I think especially in the world of more complicated waste to fuels and waste to chemicals, starting small to build big is definitely the way to go. And if not because of the de-risking, it is also, and that highlights the importance of having actual commercial type demos, it is also for the sake of being able, if you start small, the projects take not just less money, but less time to develop, and therefore less development expenditure. There's less time, and Patricia, you talk and a lot about how removing CO2 today is a lot better than removing CO2 in 10, 20 years. So if we're able to start small to medium and go large, you can start having environmental impact. You can start saving the environment a lot sooner, and even before 2030, not necessarily have to wait till 2030. So I think those are the two key points. We need, to look more at decentralized projects. Of course, as Karl said, though, that does make it slightly difficult on the CCUS bit, but it does work on the waste side. So I think we need to all work very closely with the government to address how they will support decentralized solutions. The CCC report update last year to the government also highlighted that actually over 40% of industrials are located outside of clusters. So it's not a small number as well. Decentralized solutions are needed, and are not needed just for future fuels and molecule production. They're needed for existing operations today.
Okay, thanks for that, Amna. I'm going to come to Alberto and Paula. There's been a question about metrics. What's a good metric to use? Is negative emissions a sensible metric? Others asking about fugitive emissions and net atmospheric impact. There have been comments, obviously, on efficiency and so on, and resource efficiency. So, Alberto, thoughts on what you would use as a metric to distinguish the good from the bad in BECCS? And then it'll be the same to Paula.
Well, definitely, since the objective of BECCS is to...
Oh, we can't hear you, Alberto. Or at least I can't. That may just be me.
I don't know. It seems...
I can hear you.
Okay. So can you hear me now, Patricia? No?
I can hear Alberto.
Okay, so I will be answering a bit in the meantime. Otherwise, we run out of time. So since the aim of BECCS is to create a negative flow from the atmosphere to the underground storage, so it seems obvious that at least in the works that we have performed up to now, we are focusing on the carbon emissions, on the net emissions. So we will have both biogenic and fossil inflows and outflows. And what we are interested to be is the net impact of the system that we are investigating. So in this sense, this seems to be the key factor for BECCS. But of course, we cannot forget about other metrics. So which are the social impacts that it has, the economic impacts, because we should not forget that sustainability has 3 legs. We keep forgetting the social and economic impact. So we should not limit to the net emissions, but we also need to account the other 3 legs as well. So the ideal thing, and some of the research that we are developing now, is to find a metric. Of course, this needs to reach a consensus for everyone, because if we are using different metrics, we will have a mess there, and we cannot compare different systems. But the ideal thing would be like a metric that involves multiple factors. So
yeah, I find it fascinating, Alberto, that the UK also participates in an International Energy Agency task focused on this. And the question that we had months and months of discussion on was, what metric is it best to use for a BECCS system? And then when you move to capture utilization and storage and bring circular economy measures in as well, that becomes more complex. But Paula, anything to add from you on metrics?
Yeah, I think you mentioned as well quite a few times, whenever someone is undertaking work in LCA, there are different ways that the data that can be explained depending on the boundaries and so on. So it seems like even when many people is undertaking LCA work and looking at carbon dioxide removals or different indicators, the way people interpret these results is very different, and it can have a huge impact on the overall efficiency of the processes, meaning that we should try to speak a similar language and making sure that we are all defining and comparing the efficiency of the processes. And when thinking about carbon, what is the boundary? What are we looking at? And to be quite fair in the way that we are assessing the potential of implementing different technologies. In terms of challenges, I think this is going to be a big one, because it will be also linked to scale of the processes. Amna gave a very good example of what they're doing in Q Technologies on keeping it modular and then scaling up. So if we are working on that basis, how can this be compared in larger scale systems? Is it fair comparison 1-to-1? What other approaches we need to make sure that we implement to ensure that the metrics are consistent? So terms like, and someone put this in the Q&A, terms like negative emissions, low carbon emissions, or lower carbon fuels, what does that mean? Do we have a threshold for this? And I think that is the next challenge whenever we are reporting something that is optimized, so that we're saying is delivering negative emissions, under which basis, and that is linked to what Alberto just mentioned in papers you just published recently. It's clearly indicated, like when you compare two different scenarios, it can be can deliver very different metrics in here. So
Okay.
yeah, I think that's a challenge.
Thank you. There have been a lot of questions around resources, so I want to turn to the feedstock supplies next. And really these fall into two camps, because the presentations that we've had today, some focus around biomass that comes from grown crops or forestry residues, and others focus on waste. I'm going to start with the grown material, the carbon that's been captured via forestry or via energy crops. And I think I'm going to go to Gareth first on this one. There was a question explicitly in the chat as to whether we should have a distinction between imported and UK grown material. And there are also concerns listed in the chat around whether the scale up is an issue here. Have you done any calculations in terms of the total available supply, etc.? So maybe if we start with the UK versus imported, and then maybe see if any of our academics have done some work around that overall supply, perhaps Salman or others have. But Gareth, let's start with you.
Sure. So I mean, yeah. First thing, I mean, you'll know, or perhaps you don't know, but DRAX Power Station imports its biomass internationally. So we source our biomass from North America, from Canada and the US predominantly, but we also take little bits, minor contributions from the Baltic states as well, and every now and then a bit arrives from somewhere else. But the bulk is really the US and Canada, and that's really because we don't have enough domestic supply to support DRAX Power Station at the scale that power station is. You know, so our business is entirely dependent on importing biomass, much like many other industries are dependent on importing their raw materials. In terms of you know, how much biomass is available out there, there's been lots of work done on this. I think you know, there's a bit of a challenge here for academia and for industry in terms of kind of harking back to what Paula was just saying around some transparency on what those calculations include, how those calculations are done, because ultimately you end up with vastly different answers. So, you know, I think I've seen, you know, in terms of exajoules of energy being available from biomass, I've seen everything from the sort of low 20s up to nearly 300 exajoules. So an order of magnitude of difference of potential supply of biomass out there. And that's just sort of raw biomass, and then you have to start thinking about sustainability criteria as well, and that will obviously bring that total number down. Have we done work on this? Yes, absolutely. We look extensively at what we can source and where, and obviously make sure that it adheres to our sourcing policy and our sustainability criteria. And that's you know, on a whole bunch of different levels, but one big piece of that transparency is making sure that our biomass is certified and is third-party certified and audited, and so we make sure that we do that for the material that we use at DRAX. You know, I think it also depends if you're talking about the scale of, you know, an individual company and the ambitions that an individual company had, and then the sort of the industry-wide need of scale as well. And so, you know, part of DRAX's journey to getting to where it is today recognized that we needed a stable biomass supply chain, and that's why we invested in and built a supply chain for biomass in the US and Canada. And so now we have something like 17 pellet plants across the US and Canada that supply that material. A lot of it comes for us, it's self-sourced, it comes from DRAX, but some of it that gets exported to others as well. And we buy and trade that like any commodity. When you start thinking about the scale of the industry more broadly, that's where you know, those numbers and those ranges that I just quoted, be it in terms of exajoules of energy, or if you look at the CDR amount needed, again, you get similar numbers. But I think people are coalescing around now numbers in the low gigatons in terms of CDR needed via BECCS, so 1, 2, 3 gigatons. And that's really been the last year or so we're seeing that coming in. And there's some good papers out there by a range of different academics that show what those limits are and what those planetary boundaries are, be it water, be it any competition for food crops, etc., and what the limits are. But I think, roughly anyway, we're looking at the low gigatons in terms of sustainability criteria for BECCS.
Okay, can I ask a similar question to Karl? What do you see as the constraints there around waste supply coming in? Does it have some of the same issues? Or what is constraining your feedstock? Is it the area from which you source?
Sure.
Yeah.
Well, again, all good questions, Patricia. I guess number one, it's probably worth saying that up to this point, the UK market has probably been approaching equilibrium between energy from waste capacity and feedstock availability. So I think we're approaching a point now, and that's certainly our view, where, as I mentioned, we've got about 20 million tons of capacity, either operational or in construction or at the kind of mature stages of being developed. We think that's probably right now in terms of what the national need is in terms of the volume of unrecyclable waste. So we're at that kind of equilibrium point now. As I said, when we look ahead of time, there'll be some significant structural changes in the market. Number one, the government's looking at introducing more upstream policies and infrastructure, which will encourage people to recycle more. And we think the medium to long term impact of that will be we'll have less fossil-based waste arriving on our facilities and more biogenic-based waste. So hopefully that has a net positive impact in terms of the volume of biogenic waste coming to facilities, which is what we want as a kind of trend. Conversely, we'll also start to see the government is committed to ending biodegradable waste going to landfill. So currently we send up to 10 million tons of biodegradable waste to landfill, which becomes methane, which is far more damaging from a climate perspective. So the kind of aspirational timeframe for that is 2028. So as we approach 2028, we should start to see some of that waste that's going to the landfill move into energy from waste facilities. So again, that is net helpful. But in the medium to long term, as I kind of alluded to, the government's own targets is to halve the amount of unrecyclable waste that we see in the early 2040s relative to today. So while in the near term, we'll start to see more supply come into the market, in the medium to long term, that supply is going to be tighter, which is why we think there's a kind of inherently competitive element here, whereby energy from waste operators like us need to be working with the local authorities that supply us the waste via collection companies like Suez and Veolia, to make sure that the facilities that are on stream in the early 2040s are the most sort of carbon efficient facilities as possible to manage a smaller volume of feedstock than we do currently, which is why, again, we think using CCS as a decarbonization pathway is going to be quite important, because ideally we would have 17 million tons of unrecyclable waste being treated by 17 million tons of energy from waste capacity, which is decarbonize as much as practically possible so that the overall carbon impact of that is as low as possible.
Okay, I'm going to go to our third industrialist, Amna, and slight variation on this for you, Amna. If we've had a few questions in the chat about business models, and you've just heard comments, so if there's anything you'd like to say different to either Karl or Gareth, let's hear that. But from your perspective at Q, how important is the CDR mechanism? And is there scope for perhaps revenue streams via bio-based chemicals and circular economy? And does that vary with scale, maybe? So that was to Amna.
Yeah, I think it largely in agreement with previous comments, but they're applying to kind of more traditional forms of waste to X. From our point of view, I think the business model slightly changes, and actually just before we get to CDRs, just looking at the end molecules, we actually see huge benefits with regards to in two ways. Let's start with ETS. We see huge benefits in ETS and then the impact on councils, for example, or on the positive impact that feedstock suppliers can have by routing their waste to gasification, simply because there's less CO2 emitted and there's actually some carbon remaining in the product that is then a downstream problem rather than an upstream problem. And also, as a result of that, the molecules that we're looking to target, such as methanol, hydrogen, they're higher value than electricity. So the business model kind of changes, both from being able to compete on gate fees, but equally being able to attract higher value molecules. But then you have to look at it from a carbon circularity perspective, and that's the question. That's where the important question is: should we be using biomass and waste and routing that into the heating markets, where ultimately you'll end up combusting that fuel and letting the CO2 out, or should we actually be using it for chemicals where the CO2 remains sequestered in the form of whatever you made? And I think that's a very complicated question. I think it's more to do with perhaps you should focus biomass more on applications that you end up combusting the end product, and possibly use plastics and higher, more recycled carbon materials into things like chemicals, but then they're not bio-based chemicals. But we should leave it to the market. We should create a level playing field for the market, and ultimately all these hard to abate sectors need to defossilize. And then from an economics and business model, I know I mentioned you could potentially compete on economics because you're able to produce higher value products. Everyone is, however, trying to reduce the levelized cost of production of renewables, and it's difficult to compete on fossil parity. And I think especially long term, you can reduce that, but in getting the market going, that's where CDRs, I think, will play a huge role in helping the business case and the economics, because as well as having a gate fee if you're using waste, which is a huge advantage compared to using biomass, and also why business models for waste to X right now are more economically attractive, and in some cases where you're just producing CO2-free syngas can also compete with fossil levels. You do need CDRs and to help the business case for hydrogen and methanol, because they're a lot more capex and opex intensive. Waste to syngas, not so much, depending on the different processes. But when you look at syngas upgrading into hydrogen syngas, especially into SAF, which we see as the most capex and opex intensive route, then having the gate fee revenues if you're using waste, having the product revenue, even if it's subsidized, and then adding the CDR can really help in terms of the economics and share the benefits between the offtaker, the investor, and the feedstock supplier. So the business model is slightly more complicated in the world to X, and it is generally more expensive and difficult to compete with fossil parity. So we do see CDRs playing a huge role in that, but we've identified the challenge of there isn't a standardized carbon methodology right now in the waste world. And as a result of that, it makes it very difficult to navigate in the sector. And there's also not much differentiation at the moment between whether waste in the carbon accounting methodologies, whether it's going waste to energy or waste to fuels, except for transports, where a cycle carbon fuels methodology is adopted. We don't see that being adopted in the heating and industrial sectors, which we think is a huge shame from a policy side, because who says transport is more important than industrial, more important than heating? Policy should really be looking to create a level playing field for all the hard to abate sectors to be able to achieve their net zero ambitions. And it therefore doesn't make sense to over incentivize via actual incentives or via carbon accounting methodologies, one route over another.
Okay, thanks for that, Amna. We've got about 5 minutes left in this. I'd like to give everyone a chance to come back in on a slightly different angle on this. So what one thing do you think could be done that would move the sector forward in the timescale that we actually need, i.e. before 2030? And if I could get 30-second answers on this, that would be incredibly helpful. I'm going to start with Salman.
Right. I think that's a very difficult question. It has, it's a multi-dimensional, I would say, kind of answer.
Yeah, but I asked you for one.
Sure. So I think waste management. So I think with BECCS, we're generating a lot of waste. With gasification, we're also generating a lot of waste. I think, because this is what I do, so I know probably best, this aspect of the whole process. But what are we going to be doing with this waste? Are we going to be landfilling it? Have we considered all the, contamination or side effects? I think that's what I would see.
Okay, so what one thing do you want to be done? That's a question. not an action.
I think finding alternatives in terms of either managing the waste properly or finding secondary applications for it, because they are very different from those generated, for example. It is very, very, feedstock dependent. Depending on the biomass that we are burning, we may end up with different properties of the waste. So tailor making this to, to the UK market, for example, as DRAX is doing, for instance, I think it's going to be very impactful.
Okay, well, let's go to DRAX. Gareth, what one thing would you ask for to move this forward?
An impossible question to answer, Patricia. Many things. I think, one thing that I think that the industry has a big role to play, and I wish was done more, is to aid and assist in the sort of the transparency and sustainability around the different CDR approaches. And I think there's a real responsibility on industry to show that we're aware of this, that we're leading on this. And you just have to look at the multitude of different MRV frameworks that are out there. We need to coalesce around some agreed criteria and make sure that we're transparent and we report against those, because at the end of the day, we need to build trust in all the stakeholders across very different CDR approaches, be it BECCS, be it enhanced weathering, be it afforestation.
I think that's an excellent answer, and that could almost cue me into talking about our new Centre for Doctoral Training this autumn, but I will leave that bit until the end. I will instead come to Paula next.
Well, actually, that is linked to what I wanted to. The one I pick is skills and training. I think in parallel where the technology is developing, there should be an equal investment from the government in skills and training. We are going to need people that is trained enough and they know what they are going to do when the technologies are ready to be implemented. And this has been highlighted in many conversations around industrial decarbonization and different sectors where different technologies want to be applied to reach net zero goals.
Okay. Karl, one thing that will move this sector forward, please.
I think it's probably getting the infrastructure up and running, Patricia. So, the government is hopefully going to make an investment decision in the first two CCS clusters in the Northwest and in Teesside in the second half of this year. Subject to what the new government thinks, but let's all hope that it's a positive decision. So once we can get the infrastructure up and running, that will help individual emitters be able to start planning about piping into those overarching clusters and getting their investors comfortable with the broader concept that things are moving.
Can I follow that up a little bit, Karl? Are you confident that the framework that is currently in place is going to be adequate to move that forward? Is it just a matter of us pressing go, or do you think there's more that's needed around that infrastructure piece?
I think building the physical infrastructure is important, whether you want to compete for a UK government subsidy or you're looking to develop a project on a merchant basis using carbon removal sales, for example. So, whether you're trying to sell to Microsoft or whether you're trying to get a government support contract, either way, you need the pipeline infrastructure there. So I think that's why it's a sort of cross-cutting requirement in either scenario and essential in both cases. So that's why I think it's an important first step, Patricia.
Okay, brilliant. I've got Fabian, then Amna, then Alberto. Each of you, please. I want your one thing. So Fabian first. One thing that will move the sector forward, please.
Hi, Patricia. Thank you very much. I think one thing for me is part of what we're doing here, encouraging a collaboration between industry and academia, trying to put heads together so that we talk about it, discuss it, think of what to do, think of ways to move forward and, come up with ideas. That's the one thing.
Brilliant. That's an excellent answer. Alberto.
Yes, I want to just don't forget that efficiency is key, because probably if we focus on net negative emission, the most or the best thing will be just banish the biomass. So the biomass gets CO2 from the atmosphere and we make it disappear. But this is not feasible. This is not the right solution. We know that sustainable biomass is limited. So we need to focus also in the efficiency. So getting something efficient enough from the biomass that we are using or the resource that we are employing.
And we can say there that in addition to the very wonderful work you showed us on aviation, there was another piece of work you did, which looked at different metrics and resource efficiency per unit of biomass used.
Exactly, because we are focused always on net emissions per gigajoule that we are producing, but it's also the key to account the biomass that is needed for that. Because, as I said, sustainable biomass is limited. We need to find the best use of it. Of course, any use that is better than the fossil counterparts that we're using now is important, but we need to find the best one.
Brilliant. I'm going to give the last word to Amna, and then Carys and I just want to have a quick finish off. So Amna, last word. What one thing do you want to move this forward?
So of course, other than funding for innovation, which is difficult enough, I think I'd actually strongly agree with Alberto's and actually second Gareth's point around the requirement for the frameworks to be clarified and the transparency. But from what I'll add to that is also standardization is key among that, similar to what Gareth said, and policy uncertainty where the technology, we've been in certain situations where we've been able to bring a bankable project together, bankable contracts with obviously some technology risk involved due to the first of a kind nature, but actually all the other pieces came together, but due to policy certainty, we've had to now go in kind of slow burn type of development. And that policy uncertainty was around ETS and certification schemes, which was underpinned by the lack of clarity, lack of consistency of carbon accounting methodology in the waste to X world, combined with the fact that actually there isn't a standardized methodology where you can compare like for like. And I think as well as it's important to make a project bankable and the investor and the client understand the sustainability credentials, it's also important from being able, from a wider systems perspective, be able to actually look at different pathways, different ways to X productions, routes, etc. And on Alberto's point about efficiency, and compare them like for like, rather than kind of looking at things from a lens of only transport, from a lens of only heating. So yeah, I think that would really help.
Thank you. What an amazing set of responses from an amazing set of speakers. Carys, do you have a last slide for us, I think?
Yes, I think it's just coming up now as we speak. I just want to echo your thanks, Patricia. I think that's been such an insightful discussion and a great, just a great group of speakers there. It's been really, really interesting.
I mentioned earlier that there's going to be a new Centre for Doctoral Training this autumn. If you sign up with the QR code, they're there to your left and to your right. You have double options today. The one to the left will lead, from my perspective, I know, to the Supergen Bioenergy Hub. We have a number of new forums which are starting up, which are bringing industrialists together with academics, which is one of the things that one of you asked for in this. So see how to find out more there. We do still have spaces for this September for PhD starts, which are fully funded. So if anyone is interested in that, no matter what stage in your career or life you are at, please get in touch over that. And UKCCSRC send out very regular news updates and have a newsletter and all sorts of things going on. But Carys, over to you to finish, I think.
Yeah, so you're welcome to sign up to our newsletter. It's probably the best way to keep in touch with us as well. Our next event that we've got up is an ECR Away Day, which will be having a tour of the DRAX power station as well. So for anyone who's an early career researcher and interested in that. But I just want to say as well, thank you for all of the questions that have come in as well. They've been a really interesting set of questions that have come through. So yeah, thank you everyone, and I hope you all enjoy the rest of your weeks.